optimizing production schedules, we want to set up the why and the what and the how. The why is the complex dynamic environments in which production scheduling takes place and which necessitates an advanced solution. Now, that advanced solution, which PMC offers in conjunction with Siemens, is Preactor Advanced Production Scheduling. And we'll talk about some of the specifics of that software solution, and then we'll talk about how. How do we at PMC deploy this in your environment in order to deliver maximum benefit? And that'll be followed by a brief discussion. Okay, complex dynamic environments. Production environments are inherently complex and must dynamically respond to internal and external contingencies. The inherent complexity of creating a baseline schedule in a modern production facility is that the facility almost always produces multiple products, each of which has multiple possible routings. As the product moves through the system, the cycle times of the various operations tend to vary. Sawing does not take as long as drilling, which does not take as long as punching. In addition, depending on your processes, you might need paint or other chemicals to cure. So you must wait for a certain amount of time, but not too long, because many materials have expiry times beyond which they can't be used. So that introduces the complexity of time. And then in addition, as we move from producing one product to another, there are setups, there are teardowns, there are frequently cleanouts. These are all aspects of the inherent complexity of producing a schedule, which are also impacted by external contingencies. Changing product mix demand. What was the correct mix to serve customers in May is probably not the very same mix that's needed in June or July. Therefore, even if a good or very good baseline schedule is achieved, it simply cannot be relied upon for years or necessarily months or weeks. Also, product volume demand may change either due to changing market conditions or seasonal considerations. Frequently, there are rush orders, and a customer will insist that their particular sales order push to the head of the queue. Some orders, however, might be delayed by unexpected material shortages. So these external contingencies are all beyond the production facility's control. And then there are things that the facility wishes it can control and frequently can mitigate, but nonetheless impact the production material flow. Internal contingencies such as equipment breakdown, such as lean staff or absent staff, such as scrap, such as rework. All of these things that can happen unexpectedly in the environment, even though statistically we know that they're inevitable, even though statistically we can even tell you approximately how many times per year these may occur, we don't know specifically when these internal contingencies will arise, and therefore we need some way to respond. So you put all these together, and that's why there is a need for automated advanced production scheduling systems. So let's talk about the advanced scheduling solution that PMC provides in conjunction with Siemens, and this is the what. This is the best-in-class software solution that addresses inherent complexity, external contingencies, and internal contingencies. The core of the system will be the scheduling engine. And in our case, it is the Preactor scheduling engine, in which we'll discuss in greater detail. Now, that is going to be linked almost always to the ERP system. And the ERP system, in addition to offering amendments and changes to orders, telling us about changes to material availability, in addition to that, it is going to most likely receive the schedule that is produced by the scheduling engine so that people throughout the company have visibility on an as-needed basis to what is to be produced and when it is to ship. Now, generally speaking, the systems that have direct visibility to internal contingencies, such as breakdowns, such as the progress of orders through the system or the lack of progress, as the case may be, go by various names. Sometimes these are manufacturing execution systems or SCADA systems, but the information from these needs to feed back into the scheduling engine and in turn be reflected in the next iteration of the schedule that is released to the shop floor. The Simatic IT Preactor Advanced Production Scheduling Solution is a system which stores defined sets of shop resources and product routings. It imports orders, it imports shop floor status from the surrounding supporting systems. And with that information, it can help the production controller build a schedule and then publish that finished schedule. Preactor was originally a product of Preactor International, was recently purchased by Siemens, and it offers a complete dashboard for the production controller to generate schedules, to evaluate schedules, to use drag and drop and other mechanisms to make adjustments to those schedules, and ultimately to output reports which might be delivered on paper, might be delivered electronically, might be delivered via website to the operators or the shop floor supervisors or foremen who are accountable to produce according to the schedule that is published. Let's talk about how. How is an advanced scheduling deployment, how does an advanced scheduling deployment proceed? Now again, our methodology, although it focuses on the scheduling engine, has to take account of these supporting systems. So what PMC typically does is begin with a process of analysis and design, which includes discovery, which is very broad fact-finding, functional and technical analysis that drills into the particular issues that emerge during discovery. From that point, we design an overall system. When that system design is approved by PMC and by the customer team, PMC's deployment team implements, and we can talk more about that later. And then the implementation in various stages is passed along to the customer team that tests the outputs, that provides feedback to the deployment team, which then makes modifications, and this is an iterative process. Eventually, we are prepared to launch the system. This involves installing Preactor on the client computers at which the users will view it and manipulate it, and on the servers on which the database resides, on which the licenses reside. With those in place, we can activate production data feeds and then cut over from the old system to the new. There are many, many sub-steps involved in each of these, but I am happy to report that PMC literally has decades of experience with Preactor and with other scheduling systems that give us the background necessary to successfully execute this deployment methodology. Well, that is the overall blueprint. That is the why and the what and the how of optimizing a production schedule.